Good morning, students. In this particular video, we want to go over the review for chapter 3. Okay, so what is chapter 3 all about? Logic. Oops. Okay, so let's just get started. And as we go through the questions, then we can go ahead and add a little bit of information here and there. And so in the first question of this review, it asks to determine whether the sentence is a statement. So a mathematical statement is either true or is false. It cannot be both. Also, let me just kind of see if I can think that. Let's see. Let's try to make this better here. Slightly better. But I don't think I'm doing a good job. See if I can do this like this. Okay. Let's see. Hopefully, let's see. Well, I think we'll just have to leave with this. So it's either true or false. It cannot be a command. So it cannot be a command. It cannot be a question. And it cannot be an opinion. So it just have to be, so it has to be a sentence that conveys only one idea, and it cannot be a command, a question, or an opinion. So when it says that there are 31 days in September, this is a mathematical statement because either it has or it does not have 31 days. It is not a command, it is not a question, and it is not an opinion. It is a fact. So therefore, whether it does or it does not, okay. And of course, the question is, it will either be true or it is false. And so it in this given sentence, on this given statement, the answer will be, we'll have to now double check what's going on with September because I don't remember whether it has 31 or it does not have 31 days. Let me look at the calendar real quick. So it only has 30 days. So therefore, this statement is false. No, because the statement is always false. So wait. Oh, so the answer that we want to say is C, because it is a statement, it is a sentence that is either true or false, but not both at the same time. Okay. All right. So I wasn't really trying to say is validity. That's a different story. So it is a proper mathematical statement because it is either true or false, not both at the same time. When you look at example 2, it says, hold this for me. This sounds very much to me like a command. It's literally telling someone to do something. Go do this. Go get that. Hold this for me. So therefore, this will not be a mathematical statement because it is a command. So in the English language, we can have simple statements, for example, like the ones we just did earlier. Example number 1, September has 31 days, or there are 31 days in September. Okay. And of course, in the English language, things tend to be a little bit more complex. So therefore, we have something called quantified statements. Let's see if I could use a highlighter here. So a quantified statement will have the words like all, some, or no. It could also have the words at least. Okay, so something else that we can see here is, if we can add to this, at least. Okay. And so let's see what they're trying to ask us in this particular question. It says, express the quantified statement in an equivalent way, that is, in a way that is exactly the same meaning. And there's a part B, to write the negation of that particular quantified statement. So we have something that says no bushes, and I'm going to just, instead of saying the word bushes, I'm going to say no A are this, and I'm going to call this B. And so, and the reason why I'm saying A and B is because, of course, we can have whatever else we want there. So no plants are vegetables or something like that. So that's the reason why I'm using A and B rather than no bushes are silver. If we want to say something equivalent, okay, something equivalent, then we could say something like this, okay? All A, whatever that is, are not B, okay? And so in this particular case, for part A, all bushes are not silver. Notice that in that particular case, I took the word no and I placed it in the second part of the sentence, okay? Keep in mind that this is implying that, talks about every single bush that there is out there and that they are silver, and then, so therefore all of those are not silver. So when we want to negate this particular quantified statement, no A, RB, okay. And if we want to quantify, negate, it will not be as simple as just removing or introducing the word not. That will sound kind of weird if I say no A, RB. And so therefore, we have to think about this a little bit, from a different point of view. And so therefore, we want to use some of these words, okay? And so when it says no A, that means that if we want to say the opposite, there must be some A, okay? Not all of them. This is implying that all of them, okay? So no A, the opposite will be some A, okay? Are not B, okay? And so in this particular case, notice that I have introduced the word not, okay? You see it here in the second part of the sentence. But instead of talking about the entire, whatever it is, population or whatever it is that I'm trying to say, look, I kind of say that, oh, there might be like some of them that are not, in this case, silver. So there might be some bushes that are not silver, okay? And then therefore that contradicts the statement that none of them are silver. So when we say, well, there might be some that are not, therefore there is my contradiction, okay? And so some bushes, in this case, are not silver. Okay, let's see, I want to change my pen color here. I really would like this to be a little bit, it just doesn't want to, okay? All right, so let's just do that. And let's move on to number 4. And it says, let P, now I am wondering, I'm seeing this. No, I am recording. Yes, okay. Let P and Q represent the following simple statements. P, this is orange, and Q, this is a fruit. Write the following compound statement in symbolic form. So I'm reading right now, compound statement. So that means we're going to connect some simple statements together using the words and. So this will be the symbol conjunction, or this, oops, that we need to do a little better there. That not look good. Or, so that will be a disjunction. And then we have if and then. So we got if something, then something else. Okay, and this would be a compound statement. Okay, so this gets this sort of symbol. And then we also use, so this would be a conditional statement. This would be a conditional statement. Compound statement, it means that we're putting some of these simple statements together, okay? So we have a conjunction, disjunction, we have a conditional, then we have the biconditional, looks something like this. A statement, if and only if something else, and so the symbol will look something like this, and this will be a biconditional. Okay, see if we could just get through some of this work. It says, if this is not an orange, then this is not a fruit. And so maybe what I'm forgetting here is the negation. Uses that symbol right there. And so it says, if this is not an orange, then it is not a fruit. This compound statement is a conditional. Notice that it says, if something, then something else. Okay, so it is a conditional. So I'm expecting to see this symbol on here. If this is not an orange, so therefore that seems to be the negation of P. So, oops, I tried to do a little bit better, but it just didn't work out. If not P, then also not Q. Okay. So the way I will read this is, if not P, if not P, then not Q. Okay. Alrighty then. Let's move on. Let P and Q represent the following simple statement. This is an orange. This is a fruit. We have a compound statement, so therefore we're going to use and, ors, if and thens, and then of course if we need to use the if and only if. Okay, so and of course let's not forget about our negation. So any of those, let's see what we have. This is not an orange if it's not a, if, okay, so this is a conditional. This is not an orange. Okay, so it sounds a little bit more, complex English writing. This is not an orange. Okay, so therefore it is not an orange if it's not a fruit. Oh, okay. Let me think about this for a second. I believe because of the if it's not a fruit, I'm going to assume that what they want to do here is this. So they're throwing a conditional statement here. They throw in a conditional statement here. So if it's not a fruit, so not Q, then this is not an orange. All right, and let's see what they said. I feel like they were trying to be a little bit tricky here, put in the if, not the conditional. If it's not a fruit, then this is not an orange. But let's see, they were just trying to be a little bit tricky here. Let's see, let's go to the answers and see what they say. Okay, yes, look at that. They were just trying to write a conditional statement, but they were being a little tricky there. Okay, so let's go back. So they were trying to be a little bit tricky here. All right, if it is not a fruit, then, okay. I'm not really a fan of tricking people like that, but that's just the way this program wrote this particular example. But I've reviewed the exam and we don't have anything like this. So it's going to be straightforward, okay? All right, so number 6, let Q and R represent the following simple statements. It is Saturday, and then R, we are watching cartoons. Write the symbolic statement. Oh, so now it is Q, and then don't forget this symbol is or. It's a disjunction, okay? And this will be the negation of R, okay? So we introduce or remove the word not. So it will say something like this. it is Saturday. It is Saturday. Or there is the connective, or we are not watching sports. We are not watching sports. Now, of course, there might be some differences in the way we say the English language because it is a complex language. But let's see if we can get very close to it in one of these answer choices. So it is. So let's just do this. Let's go ahead and rule out the ones that we know are not going to work out. I see it is not Saturday, so this cannot be it. If it is not Saturday, that means it would have been a conditional. So I would have seen this particular symbol there, and I do not see that. Okay, so we're down to a 50-50 chance. It's either A or D. Let's read A. It is Saturday. That's what we have. Or we are not watching sports. That looks like it's it. All right, but I'm also going to read D just to kind of rule it out. It is Saturday. Oh, right here. This is where it went wrong because this symbol is the or symbol. Okay, so that was pretty easy. Let's move on to 7. Let P and Q represent the following simple statements. P, the play is boring, just like this YouTube video. Q, the job pays well. I'm just gonna keep my mouth shut. Write the symbolic statements. Oh, okay. Seems like we're negating, okay, a compound statement. So, okay, so write the symbolic. Okay, it is. Okay. So what is common to do when we see something like this, okay, when we see a negation and then a parentheses, and then here we have some sort of compound statement, it is common to begin with, it is not true. It is not true. Not true. Wow. I'm really having difficulty writing here now. It is not true that I can write on this. It is not true that, and then whatever it is that we have. So this symbol right here, outside of this parentheses, this is the English translation. It is not true that blah, blah, blah. So what is the blah, blah, blah? The blah, 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 it's going to be this, okay? Which is the play is boring and the job pays well. So it is not true. So right now, what I'm going to rule out is definitely answer choice B. Okay, seems like C and D begins sort of the same way. It is not true. So let's see. It is not true that the play, let me make sure that the play, it's right here, that the play is boring and the job pays well. So you're probably wondering, why is he doing that? Because I want to be able to read it and compare it to what I have in my writing. Okay. So it is not true. So that's there. That the play is boring and the job pays well. So it seems like A is spot on to what I just wrote. Let's look at what C is all about. So far, I'm leaning towards A, but I'm going to check C and D and then make a final decision. It is not true that the play is all right here. This is where this goes wrong. So I am definitely 100% ruling out C. And look at option D. It is not true that the play is boring. Oh, wait, I read that wrong. Let me read that again. It is not true that the play is not boring and the job does not play well. That's not what we're trying to do here, okay? But I did not see a negation here, and I did not see a negation there. These were not, these nots should not be there. So therefore, it cannot be answer choice D. So now I am 100% sure that it must be A. Number 8 is write the compound statement in symbolic form. Let the letters assigned to the simple statement represent English sentences that are not negated. If commas do not appear in compound English statements, then use the dominance of connectives to show grouping symbols, parentheses, in symbolic statements. Okay. So, out of all of these, okay, out of all of these, negation is the weakest of in the not in the dominant world. Okay. And or they're in the same category. Okay. And so sometimes it's kind of difficult to say which one comes first. And in that case, we just treat them that they have the same, the same level. And then we have the conditional, and then we have the biconditional. So this is from least to greatest to greatest dominance. Okay. So let's see what we have here. I get sick if and only if it is not true that both I eat my fruit and I eat red meat. Okay. So I definitely see an if and only if. Okay, so this must be a biconditional statement because we see the words if and only if, therefore it takes dominance, and so therefore this will be a biconditional statement. Okay, so we're definitely going to see something that looks like that. There has to be something to the left and there has to be something to the right. If I get sick, okay, let's see. It says R, let R represent if I get sick. So, okay, there it is. There's the first part of this, all of this right here. Okay, so that's taken care of. And then we have to take care of it is not true. So therefore we know that we saw that earlier. That is the negation with the parentheses. It is not true. We saw that earlier. That both I eat my fruit, that is P, and I read and I eat red meat. And so therefore that will be Q. Alrighty then, there it is. Okay, so I remember that when I see it is not true that means that is a negation followed by a parenthesis. Okay, in this case we saw the word and, that conjunction, and there's that symbol. Okay, all right, so hopefully that makes a little bit of sense there. Let's move on to number 9. It says that let P and Q represent the following statements. There is a sum and there is a product. Determine the truth value. Okay, so if I'm going to have to do this, let's see. The truth value of P, it is true because 10 plus 10, it is equal to 20. 5 times 7, it is also true because that is 35. So we have now, let's see if we have not P and Q. That this is a conjunction. And a conjunction is only true if the following sentence or format holds. True and true is equal to true. That is the only way that we're going to get a true. Okay? In a conjunction. That is the only way that we can get a true. So therefore, when we have the negation of a true, we could do that, I guess, mathematics. This will be true. Negating a true becomes false, and false and true is a false statement. So therefore, we want to select that it is false. Okay. Complete the truth table for the following given statement by filling in the required columns. Okay, so it seems like, okay, let's just see. Just be careful with how you type this. Okay, 1, 2, 3, 4. It seems like left to right, left to right. In this case, we want to negate P. So I think I would like to see this more like that. Okay, so we're going to switch every truth value here. Every true became a false, and every false became a true. Now it says to take Q and connect it with not P using the connective and. And we saw that earlier, that in order to connect, let's say, for example, well, let's just say using the conjunction or the and, the only way that we can get a true statement is if and only if we have true and true. Every other combination will be false. So here we have in the order, we got to do this in the right order. Q and not P. So true and false will make this false. False and false will make this false. True and true, that will be true. And a false and a true will be equal to false. Okay, so what you do here is, oh, I guess, you type exactly what I just did here. So I'll let you work on the typing on your own. Something a little bit more complicated here is we got to construct a truth table. And what I like about this, it just kind of gives us every single column, and we don't have to come up with our own columns. We just need to write the correct truth value. So here is what we're saying is in this column, take everything that you see here and change its truth value. So this true will become false, false, this false, and this false will turn into truths. Now it says to take Q and connect it. So take this column, connect it with this column using the connective OR. So in OR, the only way to come up with a false statement is if and only if we have two false. Every other combination will be a true. Okay, so therefore, true or false, that will be true. False or false, that will be false. True or true, that will be true. And false or true, that will be true. The only way to get an F is if and only if we have two false. Okay, so let me erase that. Okay, and then what do we want to do at the end here? Let's see. We want to take the negation of what we just did. So this entire column here is going to change truth value. So this true will become now false. This false become true. This true becomes false. And this true becomes a false. And you're probably saying, why? This is what this column is telling us. These are the instructions. The instructions are to take everything that was in here and switch its truth value. That's what this is, the instructions. Okay, so I think I'm done with 11, and now I'm going to move on to number 12. Another truth table. It seems a little bit more complicated, but what I like about this is they're giving us all the columns. We just need to fill in the right values. So again, this column here is telling us to take everything here, let me use a highlighter. Take everything here and replace its truth value with the opposite one. So that becomes a false, false, true, and true. Let me take my eraser. So what does the next column wants you to do? It wants you to take the previous column, which is everything here, and connected with this column here using the connective and. And I think I said this a couple of times already, that if we are going to connect two simple statements with the word and, the only way that is going to be true is if and only if those simple statements are true. That is the only way that anything in this column will be true, if we have two truths right next to each other. So right now that will be false, that will be false, this will be true, and this will be a false. The reason why is because we had two truths, and that's the only way a conjunction is going to be true. And let's see, so let me erase this so that I don't get confused. And now we say, oh, let's see, take everything in this column here, connect it with this column here using the connective or. So we're connecting all of this with all of that, all of this, using the connective or. Okay. And so we saw earlier that in order for a disjunction, okay, disjunction to be false, that means that the previous two statements were false to begin with. Okay, so that's false. That's false. Okay, this will be true. This will also be true. Okay, all right, let's move on. Let's move on. Let's see what we got here. It says determine the truth value for the statement below when P is false. Q, okay, so P is false. Oh, I thought I wrote, okay. Q is true and R is false. So you will work this like you will work out any math problem, and you'll do what's inside of the parentheses first. So we have false. And then what comes out of this? This will be false. And therefore this will also be false as well. Okay. Number 14, it seems a little bit interesting here. Let's see. The line graph to the right shows the average gasoline prices for a country from 1985 through 2010. Let P, Q, and R represent the following statements. P, prices peaked in 2005. So 95, okay, so this would be 2005 here. And this would be 1995. Okay. Okay, so. All right, so this is true. The prices did peak in 2005. Prices remained steady from 1990 through 1995. 1990 to 1995. That is a lie, because it seems like by looking at this part of the graph, the prices actually increase. So therefore, that will be false. Now, what I would like to say is, if we wanted this to be true, then we said that there was a steady increase from 1990 to 1995, but that's not here, okay? If it would have remained steady, that means we would have seen a flat line, okay? And so therefore we don't see that. Therefore it is not steady. Prices were less than $2.50 per gallon in 1990. Okay, so that is also false, because right here is $2.50, and in 1990, oh, actually that is true. Okay, yes, so that is true. So good thing we looked at the graph. And so write the symbolic statement P and not Q in words. Okay, so is this like a part A and a part B to this? Yes, there is. Okay. All right. So prices peaked. Okay, so prices peaked in 2005. Okay, so I'm canceling this off. Prices peak. I'm taking that off. Okay, so I'm down to either B or D. Prices peaked in 2005, and I need to see an and here. And okay, and prices did. Wait, which one is it? Q. And prices did not remain steady from 2000 to 2000, from 1990 to 1995, and did not. So I don't see a not in here. So I am ruling out B. I'm going with D. Prices peaked in 2005 and prices did not. That would be did not Q there. Okay, so use the information given to determine the truth value. Okay, so we said that, well, I guess I'll just write this out. This will be P was true and the negation of Q, which is, okay, or maybe I should do it like this. Let me take this back. I should do it like this. Okay, maybe too many, oops, too many, okay. So that'll be, and the negation of, that was false, right? Okay, and so therefore this will be true. And the this is like negative times, I don't, let's not even think about it like that. Switch it to the opposite truth value, that will become true. And therefore true and true will give us true. So therefore we have here true. Okay. Let's move on to another example here, number 15. Oh, geez. Somebody doesn't like us. Okay, so P or P, I'm sorry, Q or R. Q or R. So we said that the only way that this is going to be false if we have false or false. Okay, so let's see. This will be true, 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 false, true, 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 false. And then they want us to take P. Okay, let me highlight this. They want us to take this. Oh, no, 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 no. Let's not do that. This is what I want to do instead. Take everything in this column and connect it with a conditional, okay, here. And so the only way that this is going to be equal to a false, and when I say a conditional here, is if we have something, something that looks like this: true, false, then therefore the answer is going to be false. Okay. And so any other combination will be true. Okay, so that we have true, true, that will be true, 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 and then a false, that will be false, false, and then a true, that will be true. This will be true. This will be true. This will be true. Okay, so again, this was the only combination where we had, let me just do this, a true followed by a false, then therefore the conditional will be a false. All right. Fill in the truth table. So here they just were getting a little bit more complex, and then another one there. It's just a whole bunch of this. Let's see. Okay. So they want us to negate Q. So that will be false. This will be true. False. True. Now they want us to use the biconditional. This will be the biconditional. And so the biconditional is only true if they have the previous two statements have the same truth value. Okay, so that's the only way a biconditional will be true, if the previous two statements are the same truth value. So therefore, let's see, we're looking at P, and so we're looking at the first and third column here. Let me just erase that. I don't know what happened there. And so we have, this will be false because I'm looking for the same truth value. This will be true. This will be true. This will be false. Okay, I was looking at the first and third column. Okay, I was looking for the same truth values, and that's why these answers are true. They want us to take P, and they want us to connect it with the conditional and not Q. Okay, so true, false, that will be false. True, if true, well, that will be true. Let's see, this will be true. This will be true. Okay, again, the reason for that is the only way a conditional is going to be false is if you have T, false, then that happens to be a false. And then they want us to take this column here, connected with this column here, using a conditional. So in this case, again, this is the only way a conditional is going to be false. And so I'm keeping an eye at 2FS, that's okay. This will be true, this will be true, this will be true. Oh, that's interesting. Every single answer here is true. Therefore, this must be a tautology. Tautology. Wow, okay. Okay, and if this would have been all false, if everything would have been all false, that is called a contradiction. Okay, and so because everything turned out to be true, it is a tautology. Okay, I think I might be scrolling a little bit too much here. If it has a combination of truths and false, then it's neither a tautology or a contradiction. All right, let's see. Another one of these. I think I'm getting tired of these. Let's see how many more of the, okay, let's see. Let's take care of this since this is the last one. P and Q. Okay, that will be true, false, false, false. Not P. Oh, okay. Wow. Wow. They actually did not give us any columns for this. Okay. Okay. So not P. Not P is false, false, true, true. And here we have not Q. That will be true, oh no, false, true, false, true. And they want this to connect this with or. So let me make that a little bit bigger because I don't, you know, I'll just keep it like that. And so this is the answer. So therefore the answers will be, in this case, the only way that this is going to be false if both of the statements were false. So false, true, true, true. And then they want us to connect this with that using an and. And so therefore that will be false, 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 which happens to be a self-contradiction, okay? All right, that was a little bit on the, because they should have given us these columns, but it is what it is. Okay, I did that on the side and it still worked out. Use a truth table to determine whether the two statements are equivalent. Oh, so this is where you need to show all your work. And let's see, maybe there's a part here. So what you need to do is you need to create two truth tables. This is the way I will do this, okay? I guess I will have a not Q column here. And then we have another column here, which is P. If P, then not Q. Let me try to do this real quick. True, true, false. I always say, let me do this real quick, and then the pen doesn't work, and it starts giving me issues. Look at that. And so here I'm trying to rush, and the pen doesn't cooperate. And also my battery's getting low, so I got to get going here. False, true, because we're negating the previous column. Okay. And so again, to get these values, I negated Q. Then they want us to connect P and not Q using the connective, the conditional. And so therefore, in this case, that will be false. This will be true. This will be true. This will be true. Okay. And in another table, I do this. Okay. Or maybe I could do it. Maybe I could do it. Let's see. You know what I'll do? I'll go ahead and just, be a little bit. I'm gonna save this for sure. We don't want to erase that, but I'm going to erase something so that I don't create too many tables. So I'm taking advantage of what I already done. So I want to show this. I want to, I want to show this here. But in order to do that, I need Q conditional with, okay, so if Q, then not P. So I need a column here for not P. So in this column, I went ahead and negated P. Now, the conditional, the order really, really matters. So therefore, true, false, that will be false. This will be true. This will be true. This also be true. And now, if we compare row for row, final answers, we see that they are exactly the same thing. So we can say that these two statements are equivalent. Okay, so this is the symbol that we use in logic for equal, equivalent. And so because row for row, they were exactly the same value. Okay. But had one of these be different, just that one, let's just say, for example, let's just say this one was different, then they would have not been equivalent because it must be every single row that they're match. Okay. So in this case, it was a true match, row for row. All right, moving on. Says write the converse, inverse, and contrapositive of the following statement. So this is a conditional. This is a conditional. And so a converse is a conditional statement where we switch the order. Okay. And in a contrapositive, what we do is we actually switch the order and also throw in some negations. And I think I missed one here, inverse. I don't know why I missed the inverse. That's just taking a conditional and negating the first part and the second part. So putting these together becomes a contrapositive. Okay. The thing about it is that the conditional and the contrapositive, they are equivalent statements. Okay. The conditional and the contrapositive are equivalent statements. And it so also happens, it so also happens that the conditional and the inverse of the converse and the inverse of a conditional happen to also be, okay, equivalent. Okay, so if Mexico is not an island, so what I want to say is P is Mexico is an island. And then Q, notice that I removed the knots in it so I can use some, some symbols. Australia, Australia is an island. So the conditional that we're starting with is the following. If not P, then Q. That's the conditional that we're starting with. The converse will be if Q, then not P. Again, this is what we're starting with. So therefore, this is what we're going to swap and negate and whatever. The inverse will be negating the beginning, negating the end. So negation and negation turns into non-negation. Okay. And the contrapositive will be swapping the order and negating. So if not Q, then P. Okay, so in this case, now that we have all the work here, the converse is Australia is an island. So I could probably just rule this out right here because it doesn't begin with, with Australia. If Australia is an, I could just also rule out that. And if Australia is an island, then Mexico is not an island. The inverse of the conditional, we're going to say that Mexico is an island. So therefore, rule out everything that begins with if Australia. It needs to be a conditional. So it needs to have if Mexico is an island. Therefore, the only possible answer here is B. And then the contrapositive will be if. So again, we need to rule that out. If Australia, so therefore, not going to work out here. If Australia is not an island, so therefore, rule out that. Okay, then. Okay. And so therefore, let's see, moving on to 20, write the converse. More of this. I don't know if I want to do this. I think I read there one example. That was enough. Use the Morgan's law to write the file. Okay, so what are the Morgan's laws? If we negate something that looks like that, that will be equivalent to not P or not Q. And there is a second one that says if we negate this this junction, that will be equivalent to not P and not Q. Okay, so it has some similar errors to distributing. I would just be careful there. So in this case, it is not true. That would be this right here. It is not true that fish and salamanders. Okay, so we want, okay, so if fish, so I don't know, P and Q, okay, I didn't see anything other special there. So I want to say something like this. Fish do not have feet. So I want to write this, which would be fish do not have feet, or salamanders do not have feet. So this will be the right answer here. Okay. All right, because this and becomes an or. So this was a good giveaway here. Use the Morgan's law. Okay, so again, same idea. So let me just, if we do this, that's equivalent to negating P or negating Q. Okay, here we have P or Q. All right, and then let's see, what do we have here? That would be not P and not Q. But I have a feeling this one is going to be a little bit more difficult or complex or trying to throw like a curveball there. Let's see. It is not the case. Okay, there it is. It is not the case, open parentheses, that my report was poorly written, or my report got an A. Actually, straightforward. Or I got an A. So therefore, I want to say something like, my report was not poorly written, and my report did not get an A. Okay, so again, I'm looking for, so definitely not this. It is not a conditional. Again, I don't think it's going to be C. It's either A or B. So again, we're looking for, my report was not poorly written. Okay, and there it is. There is the end that I'm looking for. Okay, and my report did not get an A. Okay, so that's what I was looking for there. All right, 23. Use the truth value to determine whether the symbolic form of the argument below is valid or invalid. Okay, so to not get too complicated with this, okay, to not get too complicated with this, okay, there is some tables on the textbook that you should definitely have this available to get these questions right without so much difficulty, okay? And so there are some tables out of chapter 3.7 that we can use to determine whether this argument are valid or invalid relatively quickly without getting too involved, because some of these could get relatively involved, and we don't want to do that. Okay, let's just use the information that was provided. So I saw that earlier here on this particular website because I guess didn't have the textbook in front of me, but it turns out that this is exactly what the textbook is. Okay, I believe that these people got it right from our textbook. This looks very much like the tables in our textbooks. So notice that in this particular case, they're giving us some examples of valid arguments and invalid arguments. And so therefore, what we're going to do is going to do a direct match comparison. If our example looks just like the ones here, if it is a valid argument, then we'll say it is a valid argument. So let's see, let's see if I can, so in here we have P then Q. So we have something, oh, I cannot write, okay, yes. We had P then Q, and then we have P and R, okay? P and R, conclusion, let's see, P or Q, P or R. No, wait, am I getting this right? Q or R, Q or R. And so let's see if I can find one just like that. And I am looking, and I am getting frustrated because none of these match any of these here. Let's see. We got one that looks, no, but this is definitely not the same thing. And okay, so that's a bad question right there. Let's see, maybe this one will help us out a little more. No, they did not help us a whole lot. Okay, so I'm going to just pause for a moment because I think the textbook has a little couple of more that will help us out. So I'm just going to pause the video and go look in the textbook real quick online. So give me a second. I'll be right back. Okay, guys. So I didn't find what I was looking for. I think these particular two examples are a little bit more complicated than I would have liked them. But that's just kind of, bad situation. So hopefully on the exam, because this is the review, but hopefully on the exam, you do get something of any of these forms right here so that we can make a direct distinction whether they're valid or invalid arguments. But let me work one of these out from scratch, okay? So it seems like we need P, Q, and R. So three symbols, P, Q, and R, okay? And so the idea is this. These are called an argument, or in this case, this will be a premise, okay? Premises, so this will be the first premise, second premise. And so therefore what we're going to do is we're going to connect these premises using the AND connector. And in this case, we have to only connect 2 of them, but does that lead to this conclusion? Okay, so let's see if we could just take care of some of these. So this would be true, 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 false, 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 false. Because there are 3 variables, we need 8 rows. Oh man, this is going to be interesting. Okay, so then we have, in this case, we have true, true, false, false, true, true, false, false. Then we have true, false, true, false, true, false, true, false. Okay. And now we just need to begin with figuring this out right here, which in this case, that will be our first premise. And so P, then Q, so we have true, true, that will be false, this will be false, true, 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 and also true. Then we also have P and R. Okay, well, this is fun. This is a whole lot of fun, let's just say that. P and R, so that will be true, false, and hopefully I keep some sort of order here. Otherwise, I'm going to have a jelly jam. Okay. And so what do we have here? True and that will be false. Oh no, wait. I already did a mistake there. Because I'm not keeping an eye on P. So this will be false. Oh, true. This will be false because I'm trying to do this and that. Okay. So all the rest of this will be false. Let me just double check that. True and true, true and true. Okay. And so, okay, let me just give me a second here. Okay, so getting back to this. So try to explain this column here and this column here. So what we need to do is with these kind of examples, this is called premise 1, premise 2, and we need to connect them with an AND. And this is what you see here, okay? But in order to determine whether this entire argument is true, valid or invalid, then we need to take that and do a conditional with this part right here, which is called the conclusion. If the final outcome is all true, then this entire argument is valid. But if at one point in time it turns out to be false, then the entire argument will be invalid. So this better be a tautology if it is valid. So let's see. So now again, we connecting this column with this column using a conditional. And so therefore that will be true. This 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 will be true. And this will be true. So what I'm concerned is look at the fact that each one of these values is true, depending on, regardless of whatever even happened here. Oh, but that's not what I wanted to do. Okay, regardless of what happened there. Oh no, come on. Okay, regardless of what happened here, what I'm looking for is the fact that this very last part here is always true makes, come on, I just want to be able to select my pencil, then makes the argument valid. Okay, so let me try to explain this one more time. I hope that I am recording. Yes. Okay, so the idea is this, that you have a premise and another premise. These two premises have to be connected with an AND. Unfortunately, since there were 3 variables, this table looks very, very long. But here's the first premise, here's the second premise, and here I am connecting them using the connective AND. Then I have the conclusion, which is what we have here. And then we in order to answer the question, okay, or to determine whether this particular argument, all of this is an argument, is valid or invalid, then we connect these two columns with the conditional. If the answer is a tautology, then it is valid. So in this case, it turns out that the argument is valid. Oh, I am not going to do number 24. I think we can skip on that one. But let's see, did we get this right? Let's look at 23 and hopefully, yes. And it turns out that also 24 will be valid as well. Okay. Alrighty then. Well, let's call this a wrap. Hopefully this will work out and help you out. So thank you for your time, and I'll see you next time. Bye-bye.